In today's video, we're going to be talking about systems and an introduction to systems and how we can solve them by graphing. But before we get into the new stuff, let's just talk about stuff we've already discussed, things that you kind of already know how to do, and then acclimate that to what we're going to do. Okay? So here, you got these notes in class. If for some reason you didn't, make sure you get them from whoever your teacher is. And it says change the equations into slope-intercept, so solve for y, and then we're going to graph them. So we're going to solve both equations for y, and then we're going to graph them. So if I'm going to solve this for y, I'm going to get rid of this, and the opposite of positive 2x is a negative 2x on both sides. That goes away. I'm left with negative y equals. I cannot actually subtract 8 and 2x, but I'm going to put this negative 2x first. Negative 2x, and then a positive 8. And then I get rid of this negative 1 here. So if there is a number, it's a 1, right? So we divide everything by negative 1. So y equals negative 2 divided by negative 1 is a positive 2. Positive 8 divided by negative 1 is a negative 8. Love it. It is solved for y. And now we're going to graph it. We put a point at the y-intercept, and then we do rise over run. So point at the y-intercept here, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And then rise over run. Up 2 over 1, up 2 over 1. I'm just going to keep going. And sometimes we let you just do this like once or twice and then draw a line. When it comes to what we're doing today, we need to put as many dots as possible. It's really important that the line is as straight as possible. And then as best we can, we draw ourselves a beautiful little linear function. Straight line. Perfect. Now let's do the next one. Much easier. I need to solve for y, so I get rid of this. So I subtract x. That goes away. Y equals. Now I cannot subtract 1 and x, so I'm going to put the x first plus 1. Now if you have 1 minus x, that's fine too. Perfectly fine, but I'm going to put my x's first. Then I'm going to graph it. My y-intercept is positive 1. And then my slope is negative 1. So down 1 over 1. Down 1 over 1. Perfectly. I'm going to do as many dots as possible. Go the other way. Perfect. And then we draw ourselves, oh, that is not straight, but you know, we get it. Those are my two lines. Okay, so this is a system. We'll get into y in a second. And then it has a solution. And the solution to this is where the lines cross. So let me explain that. And that's actually on the right side of your notes here. A system of equations is two or more equations. So it could be 3 equations, it could be 4 equations. In Algebra 1, we just deal with 2. It's just 2 equations. When you get to Algebra 2, you're going to start dealing with 3 equations, sometimes even 4 equations possibly. But in Algebra 1, we just deal with the 2 equations. A solution to a system is where the graphs of the equations cross. Where the lines cross, that is the solution. Okay? So what that means is, if I go over here, where do these two lines cross? Well, they cross right here, which is at 1, 2, 3, negative 2. So 3 comma negative 2 is the solution there. Perfect. So great, that's what they cross. What does that mean? What that means is that point is true for both of the equations. Here's what I mean. If x is 3 and y is negative 2, well, if I put 3 and negative 2 here, 3 plus negative 2 is 1. It works. And if I put a 3 here and a negative 2 here, well, what's 2 times 3 is 6. You minus a negative, it adds. And 6 plus 2 is 8. So it works for both of the equations. Okay? Now, a system can have, there's 3 different answers, 3 different solutions for it. A system can have one solution, which is the point. It can have no solutions, which means they do not cross. Or it can have infinitely many solutions. This is the word I always misspell. Infinitely many. Probably misspelled it. I don't know. Infinitely many solutions. Okay, and the no solution and infinitely many solutions we're going to talk about in a little bit. So just kind of hold that together for a second. Okay, so let's keep practicing that. We have this here. And our whole goal today is solve for y, graph, see where they cross. So I'm going to solve this for y. I subtract 2x. That goes away. Y equals. Can't subtract them. I'm going to put my x first, and it's a positive 2. Perfect. So y-intercept of positive 2. Slope of negative 2. Down 2 over 1. Down 2 over 1. Do it with me, please. I'm going to go the other way. Yet again, I want my line as straight as possible so I can tell exactly where they're crossing. And then we draw the most beautiful line we've ever seen. So excited. Looks great. Then the other one, I'm also going to solve for y. So I'm going to minus my x. That goes away. Negative y equals negative x plus 4. Then that's like a negative 1, right? So we divide by negative 1. Y equals a negative divided by negative is positive. It's positive 1x, or just x. Positive 4 divided by negative 1 is negative 4. There you go. So the y-intercept is negative 4. 1, 2, 3, 4. And the slope is positive 1. Up 1 over 1, up 1 over 1. Perfect. And I can already tell where they're going to cross. But I'm going to do my lines anyway. Or my dots anyway, I guess. Draw my beautiful line. And it crosses right here, which is at 2, negative 2. 2, comma, negative 2. Love it. That has one solution, 2, negative 2. That works. If x is 2 and y is negative 2, it would make both of those things true. Okay? Perfect. So let's look at a special case. This is going to be a special case one. We'll talk about y. So let's solve for y together, if we haven't already. So it's minus x goes away. I'm left with negative 3y equals negative x plus 6. I divide by negative 3. Y equals a negative divided by negative is going to give us a positive. Now 1 divided by 3. A lot of kids are going to put 3 here, but that's incorrect. If you use your calculators or our heads, 1 divided by 3 just reduces to 1/3. 1 over 3. X. A positive divided by negative is a negative, and 6 divided by 3 is 2. Perfect. So my y-intercept is negative 2, and my slope is 1/3. Up 1 over 1, 2, 3. Up 1, 1, 2, 3. Up 1, 1, 2, 3. Down 1 over 3. Down 1 over... Can I count? That's the question. And I draw my line. Perfect. Great job. Now we'll do the next one. So I minus my x on this side. It's negative 3y equals negative x minus 3. We divide everything by negative 3. Perfect. Y equals, same thing, negative divided by negative is a positive, and that'll be 1/3 x. Same thing we just did. A negative divided by negative is a positive, and 3 divided by 3 is 1. There we go. Y-intercept is 1, so we put a point at positive 1. And then up 1 over 3. Up 1 over 1, 2, 3. Up 1 over 1, 2, 3. And then down 1 over 3. Down 1 over 3. Down 1 over 3. There we go. Graph my lines. Perfect. So this is why this is a special case. Are these lines crossing? No, they don't cross. And it's not that they don't cross, it's that they're never going to cross, okay? Because they're parallel lines. They're never going to cross. So my solution, this is no solution. And why is it no solution? Because they are parallel lines. If the lines are parallel, they never cross. It is no solution. And I can already tell they're parallel. Look at my slopes here. Remember that parallel lines have the same slope? Well, my slope is 1/3 x on both of them. Positive 1/3. They're parallel, then it's going to be no solution there. Okay? Same slope, different y-intercept. So you will see that for sure. Perfect. Okay? Let's do another one together. So yet again, this is kind of repetitive, but it's the same thing over and over again. We subtract our 2x. So negative y equals... Now, just to show you, I can put the 1 first if I wanted to. 1 minus 2x. We divide everything by negative 1. A positive divided by negative is a negative. 1 divided by 1 is 1. A negative divided by negative is a positive. 2 divided by 1 is 2. And if I do it that way, my y-intercept is -1, and my slope is 2, up 2 over 1, up 2 over 1. Perfect. You do it with me. Love it. I have a line. It's amazing. Now we do the next one. So I'm going to subtract 3x. I'm going to put my x first. It just makes me feel better. I like it. And a positive 12. We divide by 2. So y equals. So some of y'all, you can use your calculators for this, but a negative divided by a positive is a negative. Can I divide 3 by 2 evenly? No. I can't reduce it, so it's just 3 over 2x. And 12 divided by 2 is 6. Perfect. So my y-intercept is positive 6. 1, 2, 3, 4, 5, 6. And then my slope is down 3 over 2. Down 3 over 2. So 1, 2, 3 over 2. 1, 2, 3 over 2. We can already see where they cross. I'm going to do the other one just in case. So they're going to cross right there. Perfect. So 2, 3. Now, these things can definitely cross at decimals. They could cross at 1.3579, 2912443. But we're just starting this process. I'm not going to give you numbers that are that complicated. But it's 100% possible for them to cross at a decimal location. Okay? Maybe if it'll go to the next slide. Sorry. So what happens if you don't have the graph and it wants to know if something is a solution? This definitely happens. You're going to see it on a STAR test, so let's go over it. So it's going to say, tell whether the ordered pair is a solution to the system of equations. Show your work. Okay, so a solution are where lines cross. But I don't have graphs and lines, right? So solution also means if it's true. If you plug it in and if it works. So we have two equations here, and it's asking if this is the solution. This is x, and this is y. So we're going to plug it in, and we're going to see if it's true. So I'm going to do the top one over here. So I have -3, comma, but instead of x, it's saying that x is 2. So I put that 2 there. Substitute the 2 in. Plus 2, instead of y, the y value is 1, equals -4. And we are going to see if this is true. So what is -3 times 2 is -6. 2 times 1 is 2. Let's see if that's true. -6 plus 2 is -4. And does -4 equal -4? Yes. So the top one's good. It's the solution for the top one. Let's see if it's a solution for the bottom one. So instead of x, I just put 2. Plus, instead of y, I just put 1. Equals 3. Well, obviously that's true. 2 plus 1 is 3, right? 3 equals 3. Love it. So, yes, 2, 1 is a solution because it works for both equations. Because it works for both equations, it's a solution, we're good to go. Okay? Love it. So then, let's try the next one. Same concept. This is x and this is y. Use the top one. So 2, instead of x, x is 4, plus 2, y is 2, equals 12. Let's see if that's true. 2 times 4 is 8, plus 2 times 2 is 4. Is 8 plus 4 12? Yeah. It works. So the top one works. Let's see if the bottom one works. So I'm going to switch colors. It says y equals, so the y value here is 2. 5x, so 5 times 4 minus 3. So let's see if that's true. 2 equals, 5 times 4 is 20. Is 20 minus 3 2? No, 20 minus 3 is 17, right? So no, that is not the solution. It does not mean it's no solution. There could be a solution here, and on this one actually there is. There is a solution. But 4 2 is not. So no, 4 2 is not a solution. Because it's not true, it does not work. Okay? So there you go. We're graphing the two lines. It's a system. There's more than one equation there. Where they cross is the answer. If they never cross, it is no solution. The only thing we didn't have an example of that I want you to write down is right here where it says infinitely many solutions. If it's infinitely many solutions, that means that it is the same line. So if it wanted me to graph y equals 2x plus 3, and then it wanted me to graph y equals 2x plus 3, and it was the exact same line, that's infinitely many solutions, because it's the same line on top of each other. Okay? There you go. That's your notes. If you have any questions, let us know.